Welcome back to the Refactoring Failure Rose. What we do on this channel is we look at this application from 20 years ago called Paley Rose, and we're trying to refactor it and make it a more modern Mac app. It's been a while since my last video. Life gets in the way. And I've come to realize it's really a decision time. What are we going to do with this thing? As I mentioned in the very first episode, that I was struggling. Should I chuck this application in the garbage? Should I release it open source? Should I make it commercial? But now it's come to another decision time. And this decision time is about what went wrong and what we're going to do about it. So if you remember, the application was a bit of a mess. When I wrote it, I really didn't understand design patterns and how to do things. And so the memory system looked a bit like this, for example. It was a real mess. All sorts of communication going off in weird ways. They didn't make a lot of sense. And so my goal was to change from this to something more like this, where it's a little cleaner. There's fewer objects talking to the memory store, and so on. So what I was doing between the last video and this video was building out a system to store the data into SQLite. This was a big thing. And I think I mentioned last time was that it's probably a mistake to build your own library to do that. And that's what I was doing. And it likely was a mistake. I like what I built so far, but it was way too much energy, way too much effort. And I'll probably keep using it, but it's again, part of the decisions. You make mistakes. Everybody makes mistakes when building software. So one of the motivations of building this new library is that there were a lot of, like I said, design problems, but there were more problems popping up as I went along, including bugs, more spaghetti code, a lot of tight integration between objects. Fighting Apple, not that Apple was wrong, it's just that I was fighting what Apple has set up to do it my own way. And I got stuck with these bad decisions. And I also had this same problem of no single source of truth, which still exists in the app. All of this stuff still exists in the app. But let's talk about bugs first. So I started noticing little things like one of the tables in the UI was not updating properly. That's a minor thing. But then I noticed things like the database was not being updated properly. Everything started to seem to be a mess. Nothing was working the way I was expecting to. It should have saved data, but it didn't save it correctly. And when it did save data, it often duplicated the data in the database, which is not what I want. And so that was part of my motivation to build up this replacement database system. So that's just the tip of the iceberg. There was a lot more going on that I kept seeing little problems here, little problems there. And part of those problems were this code was very spaghetti. It's kind of hard to think of object-oriented code being particularly spaghetti, but it was very hard to understand and hard to follow because too many things were, classes were doing too much. They were talking too many things. And there was too much tight integration. And a lot of this was caused by stream of conscious type development, where I was just, okay, I want to do this now. I want to do that now without any real thought behind it. And as I mentioned before, I didn't really have a good understanding of design patterns. To be honest, I probably don't know all of them, but I know more than I did then. Lack of testing. A lot of the testing that could have been done back then wasn't done because, frankly, a lot of the unit testing stuff we have today wasn't available, and what was available was hard for me to understand because it takes a little bit of effort to build your code to be testable. And quite clearly, I didn't refactor much back then. whatever I had, if it worked, I stuck with it. And that's what a lot of developers do if they don't have more of a corporate mindset, is that they'll just stick with what they have and resist changing it. I take it back. Even if you have corporate mindset, you will find that as well, that you just resist touching it because it works, you think. But if it's not tested, you don't know if it's really working. So let's talk about the tight integration for a moment. Tight integration is when classes know too much about other classes. If you have been paying attention to Apple's developer conferences over the last 10 years or so, you would see a lot of talk about protocol-oriented development, where you just define protocols, which basically define interfaces, kind of like header files, and you conform your types to those protocols. And that's a way of breaking tight integration. If you have a class that depends exactly on these other classes, and you have to build those classes at certain times, it makes everything difficult to break apart later. So you don't want to know too much about other types. Yeah, and you want to make sure all those details are only surface level and generally in a protocol. And you also don't want your classes doing too much, because that also forces you to make connections to a particular type that you may not want. So there's a lot of things going on with that. So fighting with Apple, in other words, fighting the system, created all sorts of additional problems. So again, most of these problems were based around SQLite. SQLite was originally chosen because it was going to be a random access data way of handling data. XML, JSON, and those sorts of things are sequential data stores. In other words, you can only read and write to the whole thing at once. But SQLite provides you random access, so you can access individual parts of the data set. So there's advantages to it, but the question is, do you really need that? SQLite was also chosen for performance at the time. It's still a really good database. Don't misunderstand that. But for the system itself, it was a really good way to have a performant way of storing the data. And one of the last reasons why we're using SQLite is because it's an open format. I have a preference for open formats for my apps, for the data, apps to store data for users to be able to get their data out if they can't access my app for some reason. But it went wrong because of bad database design and not using Apple's tools. So there's a lot of tools that Apple provides that you can use to store data, and I wasn't using any of them. So it was all custom code. And partly it was custom code because things like core data or anything like that was not around yet. And it was just better to write my own code. So again, we're mainly trying to fight this no single source of truth problem. So that is being handled by this in-memory store, which was the SQLite in-memory store. So the way the SQLite works is we read and write to the in-memory store, and the in-memory store then reads and writes from disk. So it seems like that's a single source of truth, but it isn't, because you can pull the data out of the database, make changes, and not necessarily update the database right away, or the database becomes out of sync with what the app is actually using. Now, the goal here is that we have this document model and this other design that will become the single source of truth, and we're always going to be talking to that document model to update the data and to display the data. But we're not there yet. Our goal, though, is to get rid of it, or take this in-memory store, isolate it as much as possible, and then get rid of it out of the app. And based on all of this, we're going to have to come up with a new file format in the future if we're going to continue. So SQLite is a nice tool, but it may not be the right tool for this project, at least not in the modern state. So decision time. Does this project continue? I'm going to try. This lapse gap between this video and the previous video is a sign that, life gets in the way of these things. These side projects, my day job, my family takes precedent. I might have maybe an hour a week to work on this project. So it's going to take time for me to jump in, do a video, and make some real serious progress on the project. I'm going to keep trying to keep it going. Hopefully do better than I have since in this particular case. But we're still going to continue. And one of my stated goals originally was to support as far back as I can in terms of macOS. I'm really questioning that right now, and I've decided that I'm no longer going to keep that as a goal. So it's not going to be the oldest supported Mac. It's going to be based on other criteria. And that criteria is, does it support async await? Does it support combine? And does it support SwiftUI? All those things have to be supported for me to choose an OS. Do we continue with the plan of switching from Objective-C to Swift slowly? If you remember, my goal was to, as I was working through, switch to Swift as needed. I've really come to realize that this is actually a bit of a roadblock. But there's probably somewhere in the order of at least 40 files or so that are Objective-C still. That's a lot of code. And doing it slowly is actually going to cause problems in the long run. So we can't do it all in one fell swoop, but we can do the switch to Swift relatively quickly. And that leads us to our next item is Swift AI code completion enough these days? Apple promised us Swift Assistant last year at WWDC, and maybe it'll come to fruition this WWDC. But the world of coding has changed a lot in the last year or two. It used to be we just banged our way, typing and typing to write the software. But no more. Whether we like it or not, AI is becoming a bigger and bigger part of the programming pipeline. And after having some really good experiences with AI, and good, I mean learning, sometimes the process was good, sometimes the process isn't good. But overall, in terms of learning, I had a lot of good experiences. And I've come to the conclusion that I'm just simply going to have to not be a curmudgeon, get with the times, and use AI appropriately. And interestingly enough, AI can do the job of switching from Objective-C to Swift relatively quickly. So these changes are meant to be for me to be able to complete this project. Right now, it just takes an immense amount of time for me to go through, figure out what to do it, make the video, and so on. But realistically, if I want to also learn about how to do programming of the future, I'm going to have to bring in AI, and that will speed us up. AI can easily take 2 or 3 days work and boil it down to a couple of hours. So these are the decisions I'm making right now. So I have a lot of code that's going to go into the repo that have been updated for the database stuff. It's not necessarily in a great state, but it's going to go into the repo, and we're going to move forward fairly straightforwardly from this point. Now, I will say I've already converted all the Objective-C files to Swift. However, it's not quite what you think. So here we are in Xcode. We are wanting to talk about what I've done with Objective-C to Swift. And what you'll see in the project, if you pull it down, is that all over the place, we now have Swift files and Objective-C files together in the project. One difference is none of these new Swift files are actually in a target. SwiftLint will lint these files, and they're not in good shape lint-wise. But this stuff is just exactly what an AI system converted from Objective-C to Swift. So if you look at this code and compare it to this code, it looks very, very similar. And that's not really surprising. The translation is pretty literal between Objective-C and Swift. And I don't really necessarily feel bad about that, because that's what I really want. I want to decide how to refactor it. Simply switching from Objective-C to Swift, that's a different matter. I just want it to be as literal as possible. So what I can then do is, one by one, take a look at these and see if they do what they're supposed to do. What do I mean by what it's supposed to do? Well, I can run the code, examine how it works one way, and then switch from Objective-C to Swift and see how it works the other. It also gives me a chance to write unit tests, which I'll probably have the AI do, because that's a lot of work, and run it against the original Objective-C classes, and then run them against the Swift classes and see if I have matched their functionality. That's going to be a lot. So I'm going to do a few examples in the next video, I hope, and go through that process with using AI. Now, the AI I'll probably use is a Windsurf. Windsurf uses a bunch of different models, the Claude model, and a few other models, as well as their own SWE model. And we can go ahead and start using these models to start pushing us through. But the thing is about these models and AI, we still have to know what we want. And we have to be able to identify what kind of code behaviors we want. So for right now, I'm going to stop here. I'm going to commit everything, push it up. And now we'll have these transliterated copies of Swift files that we can start migrating away from Objective-C. And that will make everything in a little bit of a better spot as we move. Next time, we're going to identify exactly what version of the OS we want to use. We want to be able to bring in, again, async await, combine if we want to, and Swift UI if we want to. So all that is coming. This has been kind of an important transition. Hopefully we can move forward, and hopefully we can all learn something about refactoring and also bringing AI into the equation. So until next time, my name is Tom Moore, and this has been Refactoring Paley Rose. Have a great one.